All right, in this video, I'm going to give you a bit of an application to inverse matrices. This is a cryptography application. And if you don't know what cryptography is, it's basically taking some sort of a message and making it so that it cannot be read. This would be particularly useful in kind of like a military situation where you're trying to send a message to your allies and the message has to travel across enemy lines, and you want to make sure that if it's intercepted, that the message can't be read by the enemy. Okay, so we're going to encrypt the message math rules using the alphabet table that you see on your screen here and a coding matrix of C that you see on the screen. Okay, so first thing you need to do is take the message that you're trying to encrypt, and you need to assign each of those letters to a number from your table. Okay, now this is not a very sophisticated table. You can see that all we're doing is kind of working backwards. The letter Z is assigned to a 1, and then you work backwards to the letter A assigned to a 26. Okay, so let's see, the letter M is 14, letter A is 26, letter T is 7, letter H is 19, a space is represented with a 0, and R is represented with a 9, U is 6, L is 15, E is 22, S is 8. All right. Now what you're going to do is you're going to organize this into a matrix that has 2 columns to it, okay? And based on how many letters we have here, this is going to end up being a 5 by 2 matrix, okay? So the first column would be 14, 26. So notice those are just the first 2 letters from your message. And then the next column is 7, 19. Third column is 0, 9, 6, 15, 22, and 8. If for some reason you didn't have the proper number of numbers to put into the matrix to complete it, then just make that last space a 0. Okay. All right, now what we're going to do is we're going to multiply this by the coding matrix. And based on the dimensions here, we need to put coding matrix second in order for the product to be defined. Now this coding matrix can, it can have whatever elements you want it to have. Okay, we've just simply chosen 3, 2, 1, and 1. All right, now 5 by 2 multiplied by a 2 by 2 is going to result in a 5 by 2. All right, so let's say we want the first row, first column element. We know we'd have to take these elements of 14 and 26 and work with in conjunction with the 3 and the 1. So 14 times 3, if you add that with 26 times 1, you're going to end up with 68. All right, and then you just continue the process of multiplying and you'll wind up with the following: 54, 40, 33, 9, 33, 27, 74, and 52. Okay, so right here, this is known as your encrypted matrix or your encrypted message. Okay, so notice that the majority of the numbers in that matrix, they don't correspond to any of the letters, within the table. So if this encrypted matrix were intercepted by, anybody that you don't want reading it, they wouldn't have an idea of what those numbers represent. Okay. All right, so once you've encrypted the message, now you have to have a way to have a way to decode it. Okay, And basically, that's just going to require you to use the inverse of the original coding matrix, okay? So what we're going to do next is find the inverse of C. That requires us to find its determinant first, which would be 3 subtracted by 2, or 1. That works out quite nicely. So the inverse of C would equal 1 over 1 multiplied by the following matrix. It would be 1, negative 2, negative 1, 3, which then gives us, of course, 1, negative 2, negative 1, 3, since that scalar out in front is just a 1. Okay. So now we're going to take the encrypted matrix and we're going to multiply it by this inverse to kind of undo the original first step, the original matrix multiplication. And you would have to expect that whoever you're sending this message to, they would know what that original coding matrix was so that they could find the inverse in order to now decode the message, okay? So now we take that matrix, we multiply it by our inverse. Okay, so another 5 by 2 multiplied by 2 by 2 is going to result in the 5 by 2. And we'll just do the first row, first column. So that's going to be 68 added with negative 54. That's going to result in a 14. Okay. And then just continue the multiplication process. 26, 7, 19, 0, 9, 6, 15, 22, 8. And notice that those are the same letters of the original message before you encrypted it, right? All these numbers right here correspond to the same letters, okay? All right, so I know it's kind of a simplistic example, yet nonetheless, it's a pretty good application to being able to use inverse matrices.